In today's video, I'm answering the 2C IGCSE Edexcel paper from June 2018. The diagram shows a Bunsen burner. The Bunsen burner uses methane as a fuel. Methane has a formula of CH4. Give the names of two elements in methane. Well, hopefully you're aware that methane is an alkane. It's a hydrocarbon, which means it contains both hydrogen and carbon. When methane burns, it reacts with a gas in the air. Give the name of this gas. So it burns in oxygen. Name the two substances that form when methane burns in plenty of air. So the key word here is plenty, which means complete combustion has taken place, and that produces carbon dioxide and water. Part 2. Name the poisonous gas that forms when methane burns in a shortage of air. So the key word here is shortage. That's meaning that incomplete combustion has taken place, which means it must be carbon monoxide, which is highly toxic because it combines with red blood cells and stops them transporting oxygen. A student uses this apparatus to investigate the burning of 4 different liquid fuels, W, X, Y, and Z. The table shows the student's results. Complete the table by giving the increase in temperature for fuels X, Y, and Z. So just pop these numbers into your calculator and you'll get 10.3, 15.9, and 11.1. The student uses the same mass of water and burns each fuel for the same period of time. Explain which fuel releases the most amount of heat energy. So you need to look along this column, the increase in temperature, and you're looking for the fuel which causes the largest increase in temperature, which is 15.9 degrees. So it must be fuel Y. So now we're explaining it. What is the name given to reactions that release heat energy? Keyword here is release, which means that they are exothermic. So I like to work out the answer before. Then I look down and see, hopefully, that my answer's there. Yes, it is. It's C. A student makes an alkali solution by dissolving a small volume of cleaning liquid in deionized water. He then titrates a sample of this solution with an acid until neutralization is complete. The diagram shows the burette readings for his titration. Use the readings to complete the table, giving all values to the nearest 0.05 centimeters cubed. So looking at before, make sure you read this nice and carefully. This is at 3.15. And look carefully at the after. And so to work out the volume of acid added, you need to take 3.15 away from 20.80 to get 17.65. So make sure you've read that question nice and clearly. B. Another student does a titration using a solution of different cleaning liquid. The table shows her results. Concordant results are those that differ by 0.2 centimeters cubed or less. Place ticks in the table to show which results are concordant. So we're comparing this row along here. So you're looking for results which are smaller than 0.2 or at most 0.2 centimeters cubed away from each other. These ones are only 0.1 away from each other. This one is far too high. This one is correct, and this one, look, that number's really high as well. So it's these three only. Use the concordant results to calculate the average mean volume of acid added. So we do 25.10 plus 25.30 plus 25.20, and then to find the average you add them up and divide by 3 to get 25.2. Bromine, chlorine, fluorine and iodine are elements in group 7 of the periodic table. Which element is the most reactive? So remember, as you descend the group, the elements get less reactive. So as you look in the periodic table, you'll see that fluorine is at the top of that group. So it's fluorine. Which element is a solid at room temperature? So the boiling point increases as you descend the group. So we're looking for the lowest member of the group, and that's iodine. And remember that iodine is a grey solid at room temperature, whereas bromine is an orange-brown liquid. Chlorine is a green gas, and fluorine is a yellow gas. which element has the darkest colour at room temperature? Oops, I've kind of already answered that, but again, it's iodine because it's a grey solid. Bromine reacts with hydrogen to form hydrogen bromide. The equation for this reaction is, the table shows some average bond energies. Use the values in the table to calculate the enthalpy change for the reaction between hydrogen and bromine. So I like to actually show the bonds, so I'm going to rewrite that equation showing the bonds. And by doing that, I can easily do bonds broken. So I can see that that's HH. So there's one of these plus one of these, which is 193. And when I pop that into my calculator, I get 436 plus 193 gives me 629. And then bonds made. Look, I'm showing all my working out and laying it out nicely. Well, I've got a 2 here, so that's 2 lots of HBr, so 2 times 366 to get 732. So the final step is to do bonds broken minus bonds made. Make sure you've got to calculate this the right way around to make sure your sign's correct. So that's minus 103 kJ per mole, and that's the final answer. Ethanol can be manufactured by fermentation or by direct hydration of ethene. In Brazil, the main source of sugar for fermentation is sugarcane. Sugarcane is added to water. Sugarcane contains sucrose, C12H22O11, that dissolves in the water. During the fermentation process, the sucrose is broken down into glucose, C6H12O6. The glucose is then converted into ethanol, C2H5OH, and CO2. Name the substance that is added to the sucrose solution to allow fermentation to take place. That is yeast, which is a fungus. Complete the equation for the conversion of sucrose into glucose. So luckily they've given us the formula of glucose up here. And to be honest, if you do biology, you should know this anyway. You need to check to see if it's balanced. It's not balanced. We've got more carbons on the left-hand side, so I'm going to put a big 2 there, and that should mean that the whole thing is balanced. Write a chemical equation for the conversion of glucose into ethanol and carbon dioxide. So just make sure you're reading it in the right order, and they've given you all the formulae above. So we're converting glucose, which is C6H12O6. We're producing ethanol, which we've been told is C2H5OH, and we're producing carbon dioxide, which is CO2. Now we need to look and see if it's balanced. Okay, we've got 6 carbons on the left hand side and only 3 on the right hand side, so I'm going to put a 2 here and a 2 here and double check. So now have 6 carbons. On the left hand side I have 12 hydrogens, on the right hand side I have 10, 11, 12, yeah, and then on the left hand side I've got 6 oxygens, and on the right hand side 6 oxygens. Yeah, it's done. Fermentation produces a solution that is a mixture of ethanol and water. Which of these is the most effective method of obtaining ethanol from the mixture? So notice that these have differing boiling points. So ethanol has a boiling point of 78 degrees Celsius. Water is obviously 100, so we're going to use fractional distillation in order to separate them, because remember, fractional distillation is used to separate liquids of different boiling points. In the direct hydration method, ethene reacts with steam. The equation for this reaction is ethene plus water forms ethanol. Name the catalyst used in this reaction. That is something you just learn off by heart, and that's phosphoric acid. State the temperature and the pressure used in this reaction. Wow, this wants a lot of detail. That's 100 degrees Celsius and 60 atmospheres. This apparatus is used to convert ethanol into ethene. Name the type of reaction taking place. Now, because you're heating, you're driving off that water, so the opposite of hydration is dehydration. You could have also said thermal decomposition. State the function of the aluminium oxide in this reaction. Well, its role is to act as a catalyst. Ethene belongs to the homologous series of unsaturated hydrocarbons called alkenes. State what is meant by the term unsaturated. It means that it contains C double bond. State the colour change that is observed when bromine water is shaken with ethene in a test tube. So just to show you what's happening from an equation point of view, here's ethene plus bromine water. Now it's an addition reaction, which means that bromine adds itself directly to the ethene. And the reactant here is orange and it turns colourless. So let's just substitute those words in here. Six, phosgene is used in industry to make polymers. Phosgene is formed when carbon monoxide reacts with chlorine. The reaction mixture is kept at temperatures between 50 degrees and 150 degrees Celsius. If a temperature above 200 degrees Celsius is used, only a small amount of phosgene is formed. Suggests why only a small amount of phosgene is formed at temperatures above 200 degrees Celsius. So notice that it is an exothermic reaction, the forward reaction. And if it's an exothermic forward reaction, then it means the high yield is favoured by a low temperature. And so because we've increased the temperature, it means that the equilibrium position must have shifted to the left. So I'm going to write the equilibrium position shifts to the left. Why? And for the second mark, because the forward reaction is exothermic. Predict how the yield of phosgene will change if the reaction is carried out at high pressure. Give a reason for your answer. So in order to work out the effect at high pressure, we need to count the number of moles. So there's an invisible one there and an invisible one there. So there's 2 on the left-hand side and only 1. So actually increasing the pressure will shift the equilibrium to the right in favour of phosgene, so you will get a high yield. Phosgene reacts with water to form hydrochloric acid and carbon dioxide. Write a chemical equation for this reaction. Let's double check the formula of phosgene. COCl2. So I've got the formula from above. It's reacting with water and we're forming hydrochloric acid. Learn the formula of all your acids and carbon dioxide. Let's double check now. No, there aren't enough chlorines on this side. Have another look. We've got 2 oxygens on the left-hand side, 2 on the right. Everything else is balanced. Perfect. The diagram shows the displayed formula of phosgene. Draw a dot and cross diagram to show the arrangement of all the outer electrons in a molecule of phosgene. Okay, so this is surprisingly complicated. So we're going to use their picture to help us draw this. I'm going to label my elements. Now, chlorine is in group 7, so it has 7 electrons in its outer shell. So we're going to do the same for both. Now I know because of this double bond here there's going to be 4 electrons in this overlap, so I'm just going to pop those in directly. And now I'm going to double check. So carbon is in group 4, so 2 of those crosses in the overlap with oxygen account for 2 electrons of the 4. Then we need to draw another 2, so I'm going to just pop them in here and then just double check how many electrons carbon now has. It's 8, perfect. How many electrons does chlorine have? 8, perfect. And then let's finish off oxygen. Oxygen is in group 6, so we can do 1, 2, 3, 4, 5, 6. Double check to see if it's full. It is, perfect. Magnesium carbonate decomposes when heated to form magnesium oxide and carbon dioxide. The equation for the reaction is magnesium carbonate goes to magnesium oxide plus carbon dioxide. A student uses this method to investigate the reaction. Weigh a clean, dry crucible and record the mass. Add some magnesium carbonate. Reweigh the crucible and contents and record the new mass. Heat the crucible and contents for 5 minutes. Allow the crucible and contents to cool and then reweigh. Repeat steps 4 and 5 until the mass of the crucible and contents do not change. The student does the experiment 4 times and the table shows her results. State why the mass of the crucible and contents decreases during heating. If we look back at the equation, it's because of this gas here, so the CO2 is a gas and escapes. State the reason for step 6. Repeat steps 4 and 5 until the mass of crucible and contents does not change. Okay, when it doesn't change, it means that the magnesium carbonate must have fully decomposed. Explain which experiment the student have heated for a fourth period of 5 minutes. Yeah, okay, so look, these are the same, so that's worked really well. In experiment 1, we can see that the mass is still decreasing, so they haven't fully decomposed that magnesium carbonate. So that's experiment 1. Why? Because the mass is not constant. Acid digestion is caused by having too much HCl acid in the stomach. A suspension of magnesium hydroxide in water can be used to cure acid indigestion. The equation for the reaction between magnesium hydroxide and hydrochloric acid is: a student investigates how much magnesium hydroxide is needed to neutralise 100 centimetres cubed of hydrochloric acid with a concentration of this. He uses 0.29 grams of magnesium hydroxide to neutralise the hydrochloric acid. Count the amount in moles of HCl in the hydrochloric acid. So I'm using this formula triangle, which states that number of moles is concentration times volume. We've been told that the concentration was 0.0968. The volume is 100 centimetres cubed, which I need to convert to decimetres cubed by dividing by 1,000. And you'll get a value which is 9.68 times 10 to the minus 3. Calculate the amount of moles of magnesium hydroxide used by the student. So this time we're using this formula triangle, which states that mass is mR times number of moles. So we're looking for number of moles, so that's mass divided by mR. We've been told the mass was 0.29 grams. The mR we've been told right here is 58. So that's 5 times 10 to the minus 3. Explain whether the student used the right amount of magnesium hydroxide to neutralise the hydrochloric acid. So we now need to compare these numbers. So in order to work this out, we need to look at the mole connection, which is up here, to work out if we had enough magnesium oxide. So to work it out, you take your 5 times 10 to the minus 3 you've just calculated as being the number of moles, and you multiply it by 2 and see if there's enough for the amount of moles that the HCl actually requires, which was 9.68 times 10 to the minus 3. Say yes, you do have enough. The flowchart shows the steps in the manufacture of sulfuric acid. The equation for the reaction in step 2 is: state what the symbols that and that represent. Okay, so the first one is that it's a reversible reaction. And that delta H shows the enthalpy change, or the heat to energy change. Name the catalyst used in step 2. Gosh, they want lots of catalysts in this paper. It's vanadium 5 oxide. State the temperature and pressure used in the reaction in step 2. Again, super specific, 450 degrees Celsius and 2 atmospheres. Sulfur trioxide reacts with water to form sulfuric acid. This reaction is very exothermic. State why the sulfur trioxide is not dissolved in water to form sulfuric acid in step 3. It produces this strange thing called oleum, it's like fuming sulfuric acid, which would be very corrosive. Write chemical equations for the reactions that take place in step 3 and step 4. Okay, so there's step 3, and there's step 4. So for step 3, I'm going to write H2SO4 plus SO3 forms H2S2O7, which you can see from the diagram. Step 4, we're taking that product, H2S2O7, we're adding water to it to form 2 lots of sulfuric acid. We have 2 industrial uses for sulfuric acid. So we can say manufacture of shampoo or soaps. Anything really, so you could also say for use in car batteries, to make fertilizers, to make paints. I'm going to write that one. Right, hope you found that helpful, guys. Don't forget to let me know how you get on in the exam and let me know